Okay, so in this topic, we're going to be looking at transforming graphs, and there's 4 different kinds of transformations that you need to know. Now, I think the idea of this topic is pretty straightforward. You could just learn about what the transformations are and just memorize them, but I want to try and give you more of a deeper understanding because it will help you answer some of the more problem-solving style questions, and it's also included in A-level maths as well with a couple of extra transformations, so it's worth making sure you know really why these things are working. So to begin with, I just want to actually work out what all of this stuff actually means. So it says here is a graph of y equals f of x. Now we kind of just want to break down some of the language that we've got here. And then we've got this rather strange looking graph, and we're going to use that to fill in this table. And then we're going to start off by doing this particular transformation that we've got down here. So it starts off by saying that the graph is y equals f of x. Well, that's just saying that the y coordinates are the output of some function when you put an input in as x. And I'm sure you probably remember from before that when you have f of x, we're saying that x is the input that you have and that the overall thing that you have of f of x is the output. So we're just saying this time, make the y coordinate be the output of some particular function that we've got here. Now, usually we don't expect to see curves that are all jagged like this. We usually expect to see them as quite like a smooth kind of thing, but it's perfectly fine to have it in this kind of context that we've got here. So this is just talking about what the x coordinate is, and then we're talking about what the output function is, or what the y coordinate is. So just reading it from the graph, when x is equal to -3, we can see that the y coordinate is 1 as we just read across from here. And when x is -2, the y coordinate is 3. When x is -1, it is 1. When it is 0, it is 1 as well. When it is 1, it goes down to -2. When it is 2, it stays at -2. And when it is 3, it goes up to 0. So we're going to be using this particular function that we've got here and this function notation to try and work out what happens when we do some of these particular transformations. So I'm going to keep using this for the next 4 examples that we've got here. So the first one that we're going to investigate is pretty straightforward. It is the transformation f of x plus a. So I'm going to look at this particular example where you take the original function, you take the original output, and this time you add 1 to all of the different values that you've got. So this is the original graph that we've got here, and these are the original output values that we said are going to be for y. But this time we're going to take those original output values, which are f of x, and we're going to add 1 onto all of them. So instead of this first one here saying a 1, we're going to increase it by 1, and it's going to go up to a 2. And I'm going to plot that point on the graph. So we have -3 going with 2. It's going to be this little point that I've got there. Then the next output was -2, which goes with 3. We're going to increase that 3 by 1 to a 4. So -2 and 4 is going to go there. The -1 goes with 1, so it's now going to go with 2. 0 used to go with 1, it's now going to go with 2. 1 used to go with -2, we're going to increase that by 1 to -1. 2 used to go with -2, and it's now going to go with -1 as well. And the 3 used to go with 0, but it's now going to go with 1. So what I can do is I can actually now draw a sketch of what is going to happen. So I've taken this original function, I've increased everything in the function by 1, and you can pretty clearly see what's going to happen here. So if I join these bits together like this, what we should see, even though it might not be perfectly neat, is that we have got the same graph that was in the blue one. I'm going to actually annotate this one correctly as y equals f of x plus 1. And what it appears to have happened is that everything has shifted 1 space upwards. So actually we can go right to this summary part that we've got over here, is that f of x plus a, it represents a translation. And not only does it represent a translation, we can actually be specific about the kind of translation that it is. Now it's moving, in this case it moved 1 space upwards because we added 1 on. If we have a added on, it's going to move a spaces upwards. Now with a vector, we can say that the top value is 0 because it's not going left or right, it's just moving a spaces upwards. So this one that we looked at over here, it moved up 1 space upwards. We could say it's a translation, and it is a translation of 0, 1. Every single point on this graph has moved up 1 position. So we can also think about how this might behave if we were talking about coordinates. Now the only coordinates that changed on this graph were the y coordinates. You'll notice here the y coordinates all increased by 1. The x coordinates stayed the same. So when I have the coordinate -3, 1, and -3, 1 was this one here, it became -3, 2. And the other coordinate was 1, -1 in the original one, sorry. 1, -1 Oh, it wasn't from this, is just could be any coordinates at all. So it wasn't specific to this one. So the y coordinates are going to increase by 1, so it's going to go from 1 to 0. And with the x, y that we have at the end, the x is going to stay the same, but the y coordinate would increase by 1. And this is specifically for this thing that we've got here. If it was an algebraic expression, so I'm going to have a couple of different examples that are not related to this graph here, it's literally going to be the same function but with the extra number added on at the end. So if the function f of x is sine x, f of x plus 2 is just going to be sine x plus 2. And then if the function were x squared plus 2x plus 3, and we're going to add an extra 1 onto it, it's going to be x squared plus 2x plus 4. And as I said here, it represents a translation 0a. So what that really means is it moves a spaces up. If it were a negative value for a, of course, it would be moving a spaces down. But in the general thing that we've got here, we would just say that it's in this notation 0a. So let's have a look and see how that behaves when we look on a graph on Desmos. So I've just drawn a random function here. I've done fx cubed plus 2x squared minus 1, and I'm going to just put f of x plus a. So I'm always going to use blue for the original and red for the translated one. And what I'm going to do, I'm going to press play next to a here. You can just type this all in yourself on Desmos. It works very, very easily. You'll see that as a becomes a positive number, or as a negative number, you can see it's going down and it's going to cycle through. When a becomes a positive number, it is just rising up that amount. And when a is a negative number, it is coming down by that amount. And obviously when a is equal to 0, it is the same original function that you've got there. So that is the first function transformation that we've got. F of x plus a is just going to represent a vertical movement of the graph. And in the next one, I'm going to be looking at minus f of x. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.